Welcome to the NSX Advanced Load Balancer Operations Workshop video series. My name is Sean, and today we're going to continue to talk about understanding NSX ALB virtual services. The topics in today's video will be advanced virtual service configurations. We'll talk about service ports, virtual hosting with SNI, as well as SSL profiles and certs. So let's dive right in. First, we're going to look at listening services. So the two software components primarily in a virtual service is how this virtual service will listen to the client communication. So we have our virtual IP address, which is the IP that client will connect to or can connect to, and then the service port. So whatever service port, whether it's 80 for HTTP, 444 through HTTPS, or even in a layer 4 communication, maybe you'll have SSH, so that would be 22. So in this diagram below, we see clients are communicating to one virtual service. Now you see two VIPs inside, but it's still one virtual service. So this virtual service has two ports currently enabled, which is port X and port Y, with two VIPs configured. So this is a common use case in a lot of in some clouds. So a cloud such as, say, AWS, you have many different availability zones that require a different VIP subnet per availability zone. So under one virtual service, you might have a VIP IP per these different availability zones. That's one use case. So if we look back at our application types, we can configure an application for HTTP, where you have that HTTP communication to the load balancer, and then HTTP to the backend servers. Another use case is where the HTTPS communication goes to that load balancer, and then it's HTTP to the backend server. This is commonly referred to as SSL offloading, where the load balancer will take care of that encryption and decryption operation. So instead of the server doing it, the load balancer does it. And this comes to our next use case, where you might have two different virtual services. One is primarily for communication on HTTP traffic, the other one primarily for the SSL communication. And since there's different components for SSL communication, such as the SSL cert and SSL profile, you could have that as a separate virtual service. So this is a different use case, and we'll go through this in a demo. Now let's jump to the demo and start looking at some configuration. So if you remember from the previous video, we configured this Avi Networks virtual service. We can first configure a new virtual service. So this virtual service will be listening on two ports. So we'll go to the create virtual service option and advanced setup. And here we have our name. So let's just call it Secure App 01. So now we're going to look at some other configuration options that I didn't cover in the previous video. Say for example, you want to build your virtual service, but you don't want it to respond to traffic right away. Well, we have this enabled flag that we can enable or disable. So if you don't want that virtual service to come up instantly, just disable it and then move on. Another option to look at is this virtual hosting VS. This is where we would enable or disable SNI. So if I click on it, I set the child instantly. And what I would have to do is I would have to set a virtual hosting parent if it's set to child. What this means is I already have a virtual service that's configured as a parent. So the virtual service configured as a parent is basically just the IP. So my IP address is going to be shared across all the childs that get created. And then when the client initiates a TLS connection, it'll indicate what the end host name it wants to reach is. And the end host name would be put here. So if I was to put secure app 01 and say example.com, the parent would respond and make sure traffic gets directed to the secure app01 example.com if it sees a client connecting to this in the SNI field of that TLS handshake. Another option is to enable parent. So if I enable parent, this will just create a parent virtual service. So the parent virtual service is the VIP address that the child will be bound to. So you have your parent and then your child. So in my case, I'm not going to use SNI. That's just a different use case. In my case, I'm just going to have a normal virtual service. I'm going to leverage a different application profile than the last video. In this video, I want it to be a secure application. So I'm going to use System Secure HTTP. Now, what's the difference? The primary difference is the security options. I have the SSL everywhere and flag enabled. If you want to find out what these different options do, just look to the last video. I go through them pretty briefly, but we also have a lot of detailed outlined in our KB articles. So I'm not going to change anything in this application profile as I'm happy with what it does. It's going to do a redirect for me. It's going to make sure all these other security options are enabled. That's perfect for my use case. Another option I want to look at is this floating IPv4. Now, since I'm using a VMware cloud, I'm not going to use it. But in other clouds, such as AWS, Azure, GCP, even OpenStack, you might be required to, say, get a public IP. So in AWS, that would be called an elastic IP. And this is where you would enable this and auto-allocate it. So the cloud connector would make a connection to the API of AWS and acquire this elastic IP or floating IP and bind it to the virtual IP. So this will enable essentially access from the internet. So any client in the internet will be able to reach this. And that's just a sample example with AWS and how it uses a floating IP. Now we have these other features, WAF policy. So this is where you would set what profile or policy you want to use for WAF. That's beyond the scope of this video, but if your use case requires WAF, this is where you would enable it. Error page profiles. So if your backend server sends, say, a specific error code, we could send the client, say, a maintenance page. So if we're expecting a certain error code from a server response, we can say, oh, that's a maintenance. Let's send this page instead of the normal page or the page the server is currently sending forward. Moving on, same as the last video, I'm going to enable the IPAM profile the same way. So perfect. I have my IP address and look, I can move forward. So I've already got a lot of the stuff configured, but let's continue. So the service is set to 443, but remember, that means the virtual service is only going to respond to 443. What if the clients are still used to talking to this virtual service on port 80? That traffic will just get dropped because this VIP doesn't listen on port 80. So we want to make sure that we're going to be listening on port 80 as well. And lastly, we have our SSL profile and SSL certificate. So what's the profile? Let's jump in. The profile is the different versions of your TLS as well as what ciphers are enabled for this SSL communication. So I'm going to use the system standard. This comes with the controller. So if you just have a generic use case, you can reuse what comes packaged with the controller or create a new one for your specific use case. So we see I have these versions of SSL and TLS enabled. Well, primarily I only have the TLS ones enabled. SSL is disabled. The send, close, notify alert. Now, just like the last video, it's hard to remember all these. So I'm going to use the tooltip for this one. Send a close notify alert message for a clean shutdown of the SSL connection. Okay, cool. That sounds pretty straightforward. We also have our prefer client cipher ordering. So we can prefer which cipher to use based on what the client's sending us. Enable SSL session reuse. We can reuse our SSL sessions. And then we have an SSL session expiration timeout. So we can expire an SSL session based on this timeout value. And now we have all these different ciphers as well. So you can enable and disable the different ciphers based off your use case. We see a lot are enabled here. If you're used to, because a lot of different load balancers have a different way to select your ciphers. And one of those ways is using a string. So if you're used to the string method, we have this box here where we can switch to a string output. And you can put in your different cipher suites or accepted ciphers in these string boxes. Now I like the list view, so I'm going to stick with the list view. And I'm not going to make any changes to my the system standard one. I'm using it across other virtual services, so I don't want to affect those. So I'm going to discard these changes. Perfect. The last thing we need to do, I want to configure a pool. I want this virtual service to serve real traffic. So let's configure a pool. I'm going to create a new pool. Now this pool is going to be on, let's say 380. And I'm going to select the servers just like we did in the last video. So these are servers that were learned via the cloud connector. Since I'm in a VMware cloud, the cloud connector will learn the different VMs that are deployed in that VMware cloud. So add those, and then I'm just going to skip all these settings. Again, I'll go through the pool and the different configuration options, but for this demo, we're just going to make it super basic and get back to that in a future video. Another option down here, you have your ignore network reachability constraints for the server pool. So this affects virtual service placement. In a virtual service placement, what occurs is the virtual service VIP, so the VIP learned from this network, is going to be placed on the front end of the service engine, so an interface for that service engine. Another interface gets placed for the back end, and that's for the pool. So you have two different IPs, your front end IP and your back end IP. What this checkbox does is it'll ignore the reachability constraints for that server pool. It'll think that, say, I can reach that pool member from my VIP interface, so I don't have to bind a backend. So in this case, your service engine might look like it's in more of a single armed configuration because it only has one interface and it's just leveraging that one interface to route to those backend pools. So we're going to click next. Policies, we're going to touch on policies a lot more when we get into modifying application behavior. But in summary, what a policy is, it just modifies your application. It modifies headers, for instance, or maybe it'll restrict traffic based on a client IP, things like that. There's a lot of customization you can do with policies. We also have analytics. So analytics we're going to touch on when we get into troubleshooting, but some very useful analytics that I like to enable, at least when the virtual service first comes up, is to log all headers. And for a new virtual service, non-significant logs are enabled for 30 minutes. What are non-significant logs? These are the logs you expect. So the real traffic, your response 200 codes and things like that. So the traffic that you deem as valid traffic. And then lastly, we have our advanced tab. So in this tab, we can configure things like performance limits. Performance limits are rate limits on the virtual service itself. We can configure rate limits in a lot of places. We saw in the last video, you can configure them in the application profile. Now in this video, you can configure them in the virtual service as well. We have quality of service options here as well. So you can set a fairness and weight it. We can change our virtual IP placement. So if you want your virtual IP to be placed on, say, a specific network, instead of trying to auto learn which network, you can do that by specifying what network that will be placed on. You can enable HTTP basic authentication to this virtual service, so it's disabled by default. We have our server network profile. So this is the backend server communication. So we can change it from the one that's configured on the virtual service. If this doesn't get set, it just uses the one that was set on the settings page for the virtual service. We also have hostname translation. So if you want to translate the hostname that, say it's coming in on a specific hostname and you want to translate it to a different hostname for the backend server, you can do that by specifying it here. Now we have some pretty useful flags here as well. We have this auto gateway configuration. So what this does is, instead of sending response traffic to, say, our default gateway, maybe we don't know where that client actually is, we'll look at the MAC that it came in on and send it to that specific MAC instead. We have a bunch of different BGP options as well. Advertise VIP via BGP, advertise SourceNet via BGP. So when our service engines establish a connection to the upstream router via BGP, we can choose what we want to advertise. We can advertise the VIP and we can advertise the SourceNet. We also have the ability to use our virtual IP as a SourceNet. So say in our single armed configuration, we could have the VIP IP as the SourceNet instead of our service engine IP. And down here, we can also specify what IP addresses we want to use for SourceNet for this specific application. Now, keep in mind for this option, if you have your service engine group set to scale out, say 3 times, you need 3 different SourceNet IPs for those 3 different service engines. So the service engines can't share the same SourceNet IP. We have a client or traffic clone profile. So this is essentially a way to clone traffic and send it to a specific server. So if I went in and create, we can specify the server address that we want to clone the traffic to. Another option is our SE group. So you might have different SE groups for different applications. So you can choose an SE group for a specific application. Remove listening port when VS is down. So if your virtual service is down, maybe you don't want that virtual service port listening anymore. So you can just select this box and it'll remove that port from any responses, whether it's an error page or anything else. We also have scale out eCMP. Now this is used for certain cloud integrations and it will disable the redistribution of flows between service engines. So I haven't had to enable this. I think in clouds it gets enabled by default, but it's good to know where this is if you ever need it. So now we can save this and we should have a working virtual service. Perfect. So it's working, it's responding. Now remember, it's listening on 2 ports, so we should be able to see the ports in this window, 80 and 443. Now maybe I want to test this application. So let's open up a new tab and I'm going to go to the HTTP endpoint, secure app 01.region 01a.corp.local. So I'm using an insecure certificate, so this was expected. Once I click advanced and I accept this, cool, the application works. So let's take a look at what we see in the actual load balancer. I'm going to check the logs. I'm going to look at the non-significant logs. And let's just look at one of the successful ones, the 200 OKs. So we see the client established a connection to the virtual service and it was on 443. Now I thought I went in on port 80. So maybe we can just do a search on port 80 instead of 443. So here's the communication on port 80, but it's giving me a 301. And the 301 is a redirect to the HTTPS endpoint. So this is expected because if you remember that application profile, it's going to do an HTTP to HTTPS redirect. So this is working as we intended it to. And lastly, remember in the analytics profile, I enabled the view all headers. Just to give a quick look on what that is I can see all the headers that are coming from the client and then from the SE to the backend server, and then from the server to our service engine or our load balancer, and then back to the client. The main thing I want to point out is what is the load balancer adding to the communication? We see this strict transport security header. Now this comes from that application profile as well. So everything looks like it's working as intended. Another thing the application profile is adding is this X forwarded proto and X forwarded for to those backend servers. So everything looks like it's working as expected so far. Another use case might be maybe you don't want that redirect to happen right away. Or maybe you want different settings for your HTTP versus your HTTPS communication. This is where you can create another virtual service. And for this virtual service, I want to use the same IP as that Avi Networks virtual service. So I'm going to call it Secure Avi Networks. And then I'm going to switch to Advanced, and we're going to select the Avi Networks VIP. And we see it's the same IP as that port 80. I'll show you when I jump back to the UI. So we'll set this one to secure. And we're even going to use the same pool. It's going to be on SSL, and it's only going to be 443. We can't put 80 as well because we're already listening on port 80 for this specific IP address. So now let's save. We're just going to skip all these settings. And perfect. Let's look at the virtual service configuration now, and we see 192.168.130.93, 192.168.130.93. So same IP address, different ports. Now we have the two different virtual services configured. Let's test them both. So first we'll test the HTTP. And we see that works as expected. Let's test the HTTPS version. And of course, my cert isn't secure, so I just have to bypass this, just proceed. And it works as well. The key thing I want to note is if I check the logs of this, let's look at how it's communicating to the backend. So I'm coming in, I'm hitting that 93 IP on port 443, and then I'm communicating 3001. So this is where I'm doing that SSL offloading. So if we check the basic virtual service and I go to the pool, since it's the same pool, they're both listening on the same ports. So the basic virtual service will be listening on, the backend servers will be listening on 3001. The main difference is they use different application profiles. So I've customized the HTTP versus the HTTPS version. That's all I wanted to discuss today. So I want to thank you for joining me in this NSX Advanced Load Balancer Workshop Operations video, and stay tuned for more topics.